So it represents the initial value, so what you're starting with, right? The initial value means at x equals 0. What is your y value? And then the slope represents the rate of change. In the dependent variable with respect to the independent variable. We talked about the rate of change yesterday, right? Or the day before yesterday when we did the y2 minus y1 over the x2 minus x. Okay, so let's look at this example. A cup of coffee is reheated in a microwave. The temperature, C degrees Celsius, of the coffee after T seconds can be modeled by the following linear equation. So we know that C is the temperature of the coffee, and T is the time in seconds. So explain what the numbers in the equation represent. How do the two equations compare to each other? So I have two microwaves. A microwave that's 500 watts, and then one that's 1,000 watts. And then it tells us that the coffee temperature is equal to 0.5 times T plus 20. And then for the second microwave, it's C equals T plus 20. So if you're looking at these two equations, can you compare them to me? Can you tell me what the numbers mean? So you have a cup of coffee, you're putting it in the microwave and you're heating it for a certain time, right? You either press 30 seconds or you press a minute, right? This shows you what's going to happen to the temperature of the coffee as the time passes by. Now, if we're looking at the first equation, what does 20 represent? The y-intercept. And we said that the y-intercept is, if I scroll back up, the y-intercept is the initial value, right? So that means that's the initial temperature of the coffee, right? So when you put that coffee in the microwave before you heat it, what was the temperature of it?
20 degrees.
20 degrees. And that's the case for both microwaves, right? So you're taking your coffee, which is the same temperature, it's 20 degrees. You're either putting it in the microwave that's 1,000 watts, or you're putting it in the microwave that's at 0.5, 500 watts. Now, if you're looking at your slope, what can you tell me about the slope? So the slope of the first one is 0.5. What does that mean? It's half of the other one, right? Yes. But what does it mean if I'm talking about if I'm gonna graph it? So I'm gonna start at 20 degrees, but what's gonna happen to my temperature every minute?
Increases.
It's gonna increase by how much? 5.5 degrees. What's gonna happen to my temperature for the second microwave for every second, sorry? It's gonna go up by 1, right? So this tells you that the temperature is gonna go up by half for every second, while this temperature, right, is gonna go up by 1 degrees every second. So if you want your temperature to be, let's say, 40 degrees, right? All what you have to do, you have to put it 20 seconds in the second microwave, right? Because 20 plus 20 gives you 40. But in this microwave, you have to put it in for 40 seconds because it's gonna only go up by 0.5 degrees every second. Okay? Does it make sense? What's happening here? Okay. So let's write that down. So the initial temperature of coffee for both scenarios or microwaves 20 degrees Celsius. The first microwave so the temperature will increase by 0.5 degrees every second. For the second microwave, the temperature will increase by 1 degree every second. Now, the two things that I need to look for when I'm looking at a line or a linear function, I need to look for the y-intercept and for the slope. Okay? Are you guys okay with this? All right. Now we're going to learn how to, if I have a set of data, and these data are basically points, right? How can I take them, put them in Excel, and graph the line and find the equation of the line that best fits? Okay? So, let's look at the next example. So it says here we can use, it's called linear regression. To model data that appear to be linearly related, and we call that the line of best fit. So, here's what's gonna happen. Like, let's say you have different points, and then you're gonna graph these points on Excel, right? What you're gonna make Excel do to you, you're gonna make Excel draw a line that best represents these data. Okay? So the numbers, they don't have to be on a straight line, but what Excel does for you, it can create a line that best represents your data. Okay? So it's like finding the average kind in the middle that best represents. To do it by hand, it's going to take a lot of work and it won't be as accurate as if we use Excel. Okay? And a lot of times when you're doing, like, let's say chemistry lab, or when you're collecting data from the government or for the government or whatever, you want to have the knowledge of using Excel, so you can put all your data in Excel and you can find the graph and the equation of best fit. Because when we do that, we can predict what's going to happen later on. Okay? So I don't have to keep collecting data for a very long period of time. Okay, so this is what the example is. So the following table shows the median age of Canada's population from 1975 to 2000. It says use graphing technology to create a plot of the data. Draw a rough sketch of your scatter plot here and describe any trends. So, if I'm going to graph this, I'm going to have x and y values, right? What's going to be on your x-axis? So the age is going to be on your x-axis?
No, the year.
The year is going to be on your x-axis.
Okay, the one at the
right? It's the one that's independent, right? So this is going to be on your x-axis, and then the age is going to be on your y-axis. Now, because I have years, 1975, I'm gonna pretend that 1975 is my year 0. Okay? So instead of actually plugging in 1975, 1980, 1985, 1990, I'm gonna put 0, 1975. So that's my first year. That's my initial study. What do I put for 1980? How many years between 1975 and 1980? 5. 1985?
10,
10.
15, 20.
So I'm looking at 1975 to be my initial year, and that's my year 0. Okay? And then if I say 1990, you know that's 15 years later, so that's your 15th, right? So that's why you put it. So here's what we're gonna do. We're gonna open Excel. And then, do you all have an Excel sheet open?
Getting there. How do we find Excel on this?
You're gonna have to search for it. So, on your first column, okay, we're gonna put the years. So let's title it year. And this is gonna be the average age. Can you guys see that?
Yeah.
Now, the years we said they're gonna go up by 5, so 0, 5, 10, 15, 20, 25. And then what did we have for average age? You guys have to help me because I don't have. So what did we have here? 27.4, 29.1, 31, 32.9, 34.8, and 36.8. Okay. Can I have your attention and I'll give you guys time to do this by yourself? So, when it comes to graphing, this is what we have to do. We're gonna have to highlight the numbers that we have created. Excel knows by itself that the first column is gonna be X and the second column is gonna be Y. I don't have to tell that to Excel. And then eyes on the board, please, and then you guys will get to do this later. You're gonna press Insert. And then you see that we have different kinds of graphs right here that I can pick from. It depends on what I want to do. If you want to do, like, let's say bar chart, you can pick these. If you want to do pivot chart, you can do this. But we're not going to do any of these graphs. We're going to pick the scatter. So it's these ones with the dots. Can you guys see that? And then you always got to pick the first one. So the one that does not have any lines connected. So you're only gonna pick the points. When you do that, you always want on your chart, eyes on the board, you get to do this by yourself, guys, please. So the things that I want from you on the chart is a title and the axis title, okay? So you see right now that I don't have any place for me to put the axis title. Can you guys see that? So what I have to do is I have to press that plus button on the side and I have to add the axis titles to it. So by that, I can actually come and say average age, right? And then on the bottom, I can say years since 1975. I have to be careful because what does 0 mean, or what does 5 mean? I have to say it's from 1975. The chart title, it's basically, you can read it or you can find it from the question. So in this case, it's the median age of Canada's population from 1975. So this is what I'm gonna have to write for my title. So median age of Canada's population from 1975. So basically, I need to be able to look at your graph and know exactly what I'm looking at. Now, what can you tell me about these points? How do they line up for you? Are they linear? Are they exponential? Are they quadratic? How do they look to you?
Linear.
They look linear, right? Good. So for me to be able to find out if they're linear or not, I'm gonna have to find the line of best fit. I know it's linear because that's what I'm studying right now. But the first thing you wanna do, you see how like your graph is kind of pretty high up, right? So what you want to do, you wanna press on your y-axis and you wanna change your scale, okay? So you make sure that you have this axis option, and then you can change your scale to minimum of, what's my minimum here? We started at 27, right? So you can say a minimum of 20. This is not mandatory, but it just makes your graph look better, okay? So instead of all the points being all high up, right, I have a better distribution for my graph, okay? So I double clicked on my y-axis and I picked my minimum value to be 20.
Minimum to 20?
Yeah, I did pick that, yes. Because my minimum value here was 27. So 20 is a good value, right? It's not too close, it's not too far. You can pick 25 if you want, right?
27 is close to 30.
Yes, but you can't pick a value that's higher than 27.
Oh,
You want to have some space, like you can't omit that. Okay, so, and here's the new thing that you guys are also gonna learn. Eyes on the board. So, for me to be able to find the regression line or the line of best fit, I'm gonna have to right click on the points, eyes on the board, and then I have to say add trend line. When I say add trend line, it's gonna be default linear, okay? Now, if you think it's not linear, if you think it's exponential, you can press the exponential button. If you think it's logarithmic, you can press this, okay? But we know that it's gonna be linear. Look how well that line is fitting your points. It's perfect fit. Along with the linear regression, you're gonna have to press display equation on chart, and you're also gonna have to say display R squared value on chart. So the two things that you see here on the bottom, you're gonna have to display that on the chart. By pressing these two, they're gonna show you the equation of the line and the R squared. Yes?
We're gonna do a test on this type of stuff, or are we gonna be using Excel?
Yes, it's gonna be on a sign.
Okay.
Okay? Are you guys okay with this? So, by doing this, I have created my equation of the line, I found my equation of the line, and I found how well does it fit. That R square value explains or tells you how well your line of best fit is fitting your points. That 0.9995, that means it's 99.95% fit. Is that a good fit or no?
It is.
That's a perfect fit, right? The perfect fit would be 1. So if it says R squared equal to 1, that's your perfect fit. Okay? Anything close to 1, the closer to 1 it is, the better the fit is. So that means I have picked the correct linear regression. The correct regression. I picked the linear one because that's close to 1. Okay? So what we're going to learn later on, we're going to learn how to do polynomial regression. We're going to learn how to do exponential regression. Okay? And then you're going to have to decide which regression do I need? Linear, polynomial, or exponential. So, if you look at this equation of the line, what can you tell me? What does this tell you?
Tells you the slope,
The slope, which is?
0.3771.
That's right. So that means every year the age is going up by 0.3771. Okay? How about the 27.286? What does that represent? That's the intercept. That's the y-intercept, right? So that's the initial value. What is the line starting at? Okay? So,
Why isn't the y-intercept the 27.2?
because remember that this line is not fitting your points exactly,
Oh,
right?
so it's their y-intercept.
It's the y-intercept of the line. That's right. Okay? Now, I'm going to teach you how you're going to copy this to a Word document, because when you're doing your assignments or when you're doing your homework, you want to copy all of this to a Word document, right? When I give you the assignment, it's going to be a Word document. Have you guys used the snipping tool before?
Yeah.
Okay, so there on your computer, there's the snipping tool. So also what you can do, you can go to the desktop. So you can go to the bottom corner, go to the desktop and start typing snipping or snip. You're gonna get the snipping tool. The snipping tool allows you to take like a picture of something that you want, okay? So you're gonna press new. And then when you press new, it's gonna give you a cursor where you can actually take a picture of your graph.
It was like a screenshot.
It's a screenshot, yeah. And then you're gonna right click, copy. Okay? When you right click and copy, you can put it in the Word document that you are using. And now it's copied to your Word document.
And then just paste on the Word document.
So copy and then go to a Word document. You don't have what?